Hello everyone, in today's video we will see how to find resultant of non-concurrent space force system. Now we know in non-concurrent force system forces are not meeting at one common point, they are acting at different points. Okay, so we have to apply equilibrium conditions to solve the numericals. So we'll see the numerical. A concrete foundation mat of 5-meter radius supports 4 equally spaced columns. Look, concrete foundation mat is having radius of 5 meter. So this is given 5 meter. But columns are spaced at a distance of 4 meter from the center of this mat. Okay. Determine the magnitude and point of application of the resultant of the 4 loads as shown in figure. So this force system is given to us and we have to find resultant and its position with respect to this origin O. Now look, this is x axis, this one is y and this one is z. Whenever the numerical is related to space force system, always concentrate on the axis given in your numerical. Now here this is x, this one is y and this one is z. Sometimes this may be x, this may be z and this may be y. So according to it we have to solve the numerical. Now whatever axis will be given, consider that axis as positive 1 and other side as negative 1. So here in this numerical this will be positive x axis and on this side of origin this will be negative x axis. So this will be positive y axis and below this mat there will be negative y axis. So this will be positive z axis and on this side of this origin, so this will be negative z axis. So if I consider the loads, 25 kilonewton load is acting on positive x axis while 100 kilonewton load is acting on negative x axis. If I consider load of 75 kilonewton, it is acting on positive z axis while the load of 125 kilonewton is acting on negative z axis. And since all loads are placed on the mat, its y coordinate will be 0 and its distance from this origin is 4 meter. Okay, so I have shown this resultant, but we will see how to show this resultant. So we will see how to solve numerical. Now look, using conditions of equilibrium. So since there is no horizontal load, I have neglected the condition summation fx equals to rx. So directly, since there is no horizontal load, summation fy will be equals to value of resultant. So again you have to assume some sign conventions. So I have treated upward forces positive and downward forces negative. So if you observe this diagram, all forces are acting in downward direction. So I will place negative sign to all my loads. So summation fy equals to r. So my resultant will be algebraic addition of all these loads acting on this mat. So this will be minus 125, minus 25, minus 75, minus 100. So if you make addition of all these loads, it comes minus 325 kilonewton. Now you will think, why minus sign is there? Here minus sign indicates load is acting in downward direction. Look, we have to concentrate on sign convention. So here resultant is of magnitude 325 kilonewton which is acting in downward direction. So this is my magnitude. Now I have to determine point of application for this resultant. Now let us assume resultant r is acting at a point having coordinate. Now look, all forces are starting with respect to this origin. So its y coordinate for all the forces will be 0. So coordinate of resultant, let us assume resultant is acting at this point. So coordinate of resultant will be x, comma y is 0. So 0, comma z. Okay. So let us assume resultant is acting at this point. Now I have to use Varigan's theorem of moment to find its position with respect to this origin. Now in space force system you have to take moment about different axes. So first of all we will take moment about x axis. Now summation mf x equals to mrx. Now I will explain you this term. Algebraic sum of moment of all forces about x-axis. M indicates moment, F indicates force, X indicates the axis where I am taking moment, equals to mrx, moment of resultant about x-axis. Now for taking moment, I have used sign convention as clockwise moment negative and anti-clockwise moment positive. You can use your own sign conventions, doesn't matter, your answer will be same. Now how to take moment? So for this I have prepared one small setup to explain you how to take moment. Now here I have used these sticks to explain you how to take moment. Now look, this is my y-axis, this is my positive x-axis, this is my negative x-axis, this is positive z-axis and this is negative z-axis. Now look, I have to take moment about x-axis. Since I am taking moment about this x-axis, what are forces which are placed on this x-axis, its moment about this axis will be 0. So I have to consider forces only on this z-axis. So which forces are acting on z-axis? On negative z-axis there is force of 125 kN which is acting over here, and its distance from this origin is 4 meter. Okay, and it is acting in downward direction. Now if you consider this force 75 kilonewton, it is acting at a distance of 4 meter from origin. Again it is acting in downward direction. So I have to take moment of only these two forces. So now we'll see moment. Now look, the force which is placed on this z axis, positive z, how it will create moment about this x axis. Now look, the force which is placed on this positive z axis, how it will rotate? Now look, this will rotate in anti-clockwise direction about this x axis. Look, this force is placed over here. Consider its direction and rotate it around this x axis. So it will rotate about this stick like this. Okay, so it will create anti-clockwise moment about x axis. Now if you consider the force which is placed on this negative z axis, how it will rotate? Now consider its direction. Now look, it will come down from this and it will rotate like this. So it will create clockwise movement about your x axis. So this force will create anti-clockwise movement while this force will create clockwise movement. So I have written same in the equation. Now look, I am taking moment of all forces about x axis. So this force is making anti-clockwise movement according to my sign convention. Anti-clockwise movement I will consider positive sign. So 75 into its distance from origin is 4 meter, means with respect to x axis, and this force will create clockwise movement and its distance from x axis is again 4 meter and it is creating clockwise movement. So according to sign convention it will be minus 125 into 4. Now consider this resultant. Again this resultant will rotate in clockwise anti-clockwise direction about x axis. This is on left side of x axis. So it will create anti-clockwise movement about this x axis and its distance from x axis is z. Now in this direction the distance of resultant with respect to x axis will be z. So its moment will be plus 325 into z. Okay, so if you solve this, your z will come minus 0.615 meter. So minus sign indicates it must act on the opposite side which I have assumed. So it will act on this side. Okay, now take moment of all forces about z axis. Now look, summation of moment of all forces about z must be equals to moment of resultant about z-axis. I am following same sign convention. Now again we will use setup. Now look, the forces are acting on. Now I have to take moment of all forces about z-axis. So whatever forces which are acting on this z-axis will create zero moment about this z-axis. Now there will be moment of only two forces which are acting on x-axis, and I have to take moment of only these two forces about z-axis. Now if you consider force of 100 kilonewton, it is acting on negative x-axis, while the force of 25 kilonewton is acting on positive x-axis. Now rotate these forces about this z-axis. Now look, this force, how it will rotate about your z-axis? It will create, consider its direction, it will create anti-clockwise movement about your z-axis, while this force of 25 kilonewton which is placed on this side will create clockwise movement about this z-axis. Now consider this position of resultant, how it will rotate. It will rotate, we have considered position at this point, means on this side of this x and z axis. So again it will create clockwise movement about this z axis like this. So put this in equation. So your equation will become plus 100 into 4. Why plus? Because it is creating anti-clockwise movement and its distance with respect to z-axis is 4 meter. While force of 25 kilonewton is making clockwise movement. So 25 into 4 equals to, now this force we have considered on this side. So let us say it is creating clockwise movement. So minus 325 into its distance with respect to z-axis is x. It is parallel to this axis. So this distance will be x. So 325 into x. So if you solve this equation, x will be minus 0.923 meter. So here I got two values of coordinates, and already we know the coordinate y is 0. So point of application of resultant will be x, y, z. So x is 0.923 meter, y is 0 and z is minus 0.615. Means this x minus indicates it must act on negative x side and z is also negative. So resultant must act on this side instead of this side. So I hope you have understood this numerical. Thank you.